Hello, this is Group 13 presenting the Smartphone Pentest Framework, that's SPF. Our names are David Asbjornson, George Liu, and Sparsh Kumar. So as long as Android and iPhone have ever been around, they've been competing, and Android's now, by 2016, captured about 80% of the market share. And it's done that by offering a bajillion different features from a bajillion different manufacturers. This has definitely been very effective in terms of market penetration, but not such a good idea in terms of security penetration. There are actually many options for Android security pen testing. Santoku's like Kali, but for Android. MobiSec is developed by a company, so it's proprietary, but the one we want to focus today is called SPF, made by Bulb Security. And here's SPF's gorgeous GUI interface. Here, that's better. This is SPF's console interface from Kali Linux. There's still a lot of options though, so we're here today to help you make sense of them. SPF is principally developed by Georgia Weidman of Bulb Security. It's meant to be run on Kali Linux on some control console, say a laptop, where its software could be uploaded to a control server connected to the internet. Now, through some social engineering, we'll send a text or a link or some QR code to our target. And once our target scans this text or link and installs our malicious app from SPF, we'll convert this phone into our own private agent. This phone will now communicate to our control server and do our every bidding, including sending further malicious messages to its own network. Rinse, repeat. This can be done by installing SPF's malicious app, either custom compiled or by taking a Google Play signed APK, decompiling it, installing our own SPF malicious code, and then recompiling it and signing it with an Android key. Once this malicious code is on your phone, it'll run in the background and communicate with our server, giving us remote control of the phone, whether that's taking pictures with the camera, reading your contacts, sending text to your contacts, or reading your installed app list. It'll also allow us to run certain exploits like Rage Against the Cage or Zergrush that'll give us root access to your phone. The blue path indicates the features of SPF today that we will teach you in today's tutorial. And in order to accomplish this, we're actually going to ask you to help us fix a bug in SPF itself located in its primary Python script, framework.py. I'd also like to take this moment to give you a short intermission where I talk about our 16-digit secret code, which is the first 10 prime numbers. There's a little puzzle for you. Our pen testing today will be accomplished on Android OS 19. That's Android KitKat. That's partially because Android KitKat's been around for a while, and yet it still has 25% of market penetration. However, it is also because it's one of the few versions of Android that'll actually run stably on our lab computers. Unfortunately, this also excludes us from pen testing certain older vulnerabilities, such as the Android master key vulnerability. Without further ado, I'd like to jump into today's tutorial. First, from SPF main interface, we want to select option 7, which will clear the cache. And then we want to select option 1, with which to first begin creating our agent and then deploying our agent. Option 5 will backdoor an existing Android APK with our agent. First, you want to download an APK from a site mirror. Google Play itself won't let you download the APKs directly. After downloading it, locate the APK's full path, give it to SPF, and SPF will begin using APK tool to decompile, then recompile, and then it'll ask you for some options. When it asks you for a phone number from the agent, this isn't particularly important. We found that it actually doesn't matter if it's the exact phone number of your agent phone. However, this is really important. Your control key must be exactly 7 characters. That is, no more, no less. Enter some character of length 7. Finally, we want to give it some target path, which the web server will use to upload Android. When it asks you to use the Android master key vulnerability, say no. The master key vulnerability will not work for APKs in Android API 19. Enter the passphrase Android, you cannot make a typo, or you're going to have to start from the beginning. So just type in every letter and then hit really carefully and hit enter. So now we've created this malicious APK. Now our job is to upload it to our web server by using option 1, then option 3, copy agent to web server. We'll create some hosting path on our web server called /flash, and in this case I'm going to rename my APK light.apk. If I will then go to my computer's IP address /flash/light.apk and hit enter, we'll find that our phone will begin downloading the APK file. In real life, you might send this link in a QR code or send it in a text. Once you click on that installation, it'll begin installing the flashlight. Notice it asks for all sorts of strange permissions for you. We'll just click past them and push install because most users don't pay attention to that stuff anyway, right? Once the flashlight is on, you'll notice it's a perfectly functional app. It does all the things the app is normally supposed to do. If you click on the screen, it'll light up and boot down. We'll go back into SPF, use option 1, and then type in our control path. This is where the target info. We'll also type in our 7-character control key and tell SPF to use HTTP communication to issue commands to its target, or now agent, phone. Again, that URL path is the location of the directory on your server where the Android emulator and the SPF are going to be communicating with each other. After you wait about a minute, you'll establish communication. And we'll note here, this is the location of our web server, which is in /var/www/html. So if you've coupled SPF and your phone correctly, you'll notice it'll display your available agent's phone number when you select option 2 from the main menu. After you're selecting option 2, it'll give you a ton of different options with which to take control of your exploited phone. In this case, we're going to send an SMS. It'll ask you which number to send it on. Right now, we've only got one emulator running, so we're going to send a text to ourselves. And after we've issued that command, SPF will drop a command into its web server, and the target phone will listen for this message and listen for these orders. And we notice that is in fact executed the order that we've dropped into our web server. If we select option 2, which is we want SPF to take a picture from our phone's camera. That will take a while. Go ahead and try it. It might take a long time for it to upload the full results of the camera's picture. We can also try out option 14, which will get a list of all installed apps. We can go back up in options by pressing 0, and then from the main menu select option 3, typing in agents and selecting our agent. Option 3 allows us to view the data that we've already captured, which if you perform a few updates, it might take a little while for the thing for the command to properly execute. You'll eventually see the what SPF has done for you. And in this case, we now have our location of the picture that's taken from our emulated phone, our emulated camera. Notice this picture is just a sort of a test pattern because SPF itself is or because our emulated phone doesn't have a real camera. And that just about sums up our lab. As a quick reminder, our lab is from 5:20 to 5:40 p.m. on Wednesday, December 7th. I'm sure you can't wait to get your hands on SPF.